and this is the second video lecture in a series to teach the principles of our physical existence as presented in my book, Are We Just Bubbles? An Alternate View of Existence. In the last lecture, we talked about the physical existence of space and how the entire universe is made solely of a finite set of invisible space bubbles. We examined how measurements are made and how our universe space is invisibly expanding into the infinite void without our detection. This proposal of physical existence that I have made is a radical deviation from the Big Bang model and what has thought to be the cause of physical reality. My ideas will likely upset the apple cart, so to speak, in the scientific community. But there are many things still unanswered in the Big Bang model, like what is time? How does light travel through space? And why does it travel at a constant speed of light? Maxwell's equations describe the behavior, but these equations do not offer a solution of how it travels in space. How are electric, magnetic, gravitational, and inertial forces imparted on bodies of matter in vacuum space? And for that matter, what is energy? It seems as though the ultimate solution of understanding universe workings cannot be made on this Big Bang model path. Scientists have even said there must be something that is being overlooked, and they need a breakthrough before we can go much further. It takes a lot of courage to explore new ways of thinking about things. It's natural to stick to things we are familiar with, and with things we have invested much time and effort in, maybe even our life's work. But if you can accept that the universe may not have started with a Big Bang, and that it could be composed entirely of invisible space bubbles that are ever expanding, I will show you in the following lectures how all of the mysteries, actions, and that we see are the result of the expansion of the space bubbles into the infinite void. What I am proposing is a grand unification theory, and it might be good to give you an idea of what is assumed and where I'm going with this. First, I assume that the entire universe consists solely of a finite amount of invisible expanding space bubbles, and there are no voids in universe space where these bubbles do not exist. Second, vacuum space consists of vacuum space bubbles, which are the most highly expanded and least restricted of the space bubbles. They are assigned a density of 1, and they are not detectable directly. Third, all matter in the universe consists of compacted clumps, yet still expanding space bubbles. These clumps are visible as matter and have a value of mass that is proportional to the density ratio of the clump to the vacuum space bubbles. And fourth, all of the invisible traits and attributes associated with the physical universe, energy, time, gravity, inertia, etc., are caused by the expansion of these bubbles and their interaction with each other. There is nothing else in the physical universe. Now, a group of lesser expanded space bubbles forms matter and has a density greater than 1. These clumps are still expanding in the same proportion as the vacuum space bubbles, though, so they appear a constant in size. The clumps of bubbles may be in different configuration and consist of various flat-sided polyhedron-shaped bubbles. These clumps come in many sizes and shapes and make up the various types of matter: subatomic particles, electrons, protons, neutrons, etc. The size and density of the clump gives them the value of mass. So what holds the clumps together? In order to answer this, I will list a set of simple rules based on logic that the bubbles must follow if the universe is to be composed solely of them. Space bubbles can only expand. They can never contract because space cannot be uncreated. Secondly, the space of one bubble cannot be shared with another. Third, there are no voids between the bubbles. Bubbles terminate on each other with flat surfaces and facets of polyhedrons. Each facet of a space bubble can only be shared with one other bubble. Shapes of bubbles can vary in size and number of facets to practically any voluminous, flat-shaped polyhedron in solid geometry. Fourth, since facets of adjoining bubbles must be congruent and bubble space cannot be shared, they interfere with each other's expansion forcefully. And fifth, since the bubbles must share sides with other bubbles, and there are expansion restrictions imposed by the boundary conditions with each other, clumps of bubbles may form in all types of kaleidoscopic configurations that are more dense than the vacuum space bubbles. So, back to the question, what's holding the clumps together? The answer is that the clumps are being pushed together by expansion and are being held together by the boundary conditions imposed by the particular geometric configurations. No voids, facet congruence, no sharing of space, etc. The only primary force in the universe comes from the expansion of impenetrable space bubbles and their actions upon one another. The infinite void, or as sometimes I call it the abyss, has no bounds in the small or large. No matter what unit of measurement you choose to use in the void, you can divide it into smaller and smaller fractional divisions to infinity. Now, I believe for anything to physically exist that we can see in our universe, it must have occupied a volume of space in the infinite void when it first came into being. Remember that the universe consists of a finite amount of space bubbles, even though there is an inconceivably large amount of them. These bubbles were point-like by our standards when they were formed, but they still occupied a volume. For our discussion, we will assume that this enormous group of bubbles was spherical in shape as it sat in the void, and that all the bubbles were uniform in size and shape with no empty spaces between them. We will assume also that at the onset of expansion, the bubbles expanded in random quantum steps relative to each other. So when the bubbles began to expand, the outermost layer had one side facing the void, which offers no resistance to expansion. The only thing restricting expansion in these bubbles was its contact with other bubbles on the sides away from the void. And so these outermost bubbles expanded in the direction of the void at a greater rate, and that side of the space bubble could have been curved instead of flat. Now, the reason why there are flat surfaces on the bubbles that are shared is due to the equal expansive forces within each bubble requiring no interface to favor one side of the bubble or the other. Thus it has a flat surface. So when these outermost bubbles were expanding into the infinite void, they had an irregular expansion caused by the irregular shape of the bubbles. And since those bubbles were not expanding synchronously, the symmetry of the outer layer was broken. Cracks in the outer surface occurred, and fissures penetrating into deeper layers were formed as the bubble expansion restrictions changed due to the broken symmetry. These cracks and fissures were made up of oddly shaped space bubbles, but they still maintain the conditions set out in the rules of behavior mentioned earlier. What I have described about the beginning of the universe is very hard to grasp because we have not experienced anything like this in our dealings with how the universe works. But what I propose is that in the beginning, the universe, when it was first formed, it was a sphere with unimaginably large amount of tiny space bubbles inside of it, each one having a source of new space material within it. Now the sphere was uniform all around, had all of the bubbles were the same size and the same configuration. I've depicted them here as cubes in this cross section. And now what we have here is just a small portion of the surface of the sphere. For illustration purposes, this is a cross section of cubes which would appear as squares here. We see that the surface, they're all still uniform and the same size. Now as the universe begins to expand from within, all these bubbles down here are restricted in their expansion by the surrounding bubbles. But on the surface, there is no restriction in the side away from the universe into the void. And so these bubbles are free to expand in that direction. Also, the bubbles are not expanding synchronously. That means that they are just at random expanding and in incremental amounts. So what happens is the symmetry is broken on the surface, and so some of the bubbles start expanding more than others, and depending upon its boundary conditions with the others, it may get bigger than the others. It may restrict others from expanding, but this will continue and it will wildly start fracturing on the surface. There will be portions of this that will have huge bubbles, others may be smaller, and eventually there will be cracks, what I call cracks in this surface, which are still bubbles, but they will be highly irregular in shape, and some of them may even spread down into the inside here and cause fissures in that surface. And this is what happened when the universe first began. It started wildly expanding and not uniformly, and so we have this broken symmetry that causes the universe to exist the way we see it today. So the infant universe was wildly and chaotically fracturing and expanding at its beginning, but not from a Big Bang explosion of energy. Rather, it was expanding everywhere from within, powered by the creative source in each space bubble. At this point in the early beginnings of the universe, there would not likely be any compacted groups of bubbles that would have formed any matter that would be familiar to us now. At this point in my lecture, I'm going to introduce the concepts of energy and time as it relates to an expanding bubble universe. It will be an introduction and not delve into details that will be covered later. Now you might be thinking, where's the energy that is supposed to be present as described in the super hot soup of the Big Bang theory? Well, therein lies the faulty assumption in that theory. With it, all the energy in the universe was present when it came into being, and all the energy is conserved during the course of its existence. it is assumed that energy is the cause of universe existence. Looking at this from an expanding space bubble universe perspective, there was no energy until the first bubbles started their expansion. The difference in this big fizz theory, as I call it, over the Big Bang theory, is that the expansion causes the exhibition of energy rather than the energy causing the expansion. The forceful expansion of each bubble from a source within causes a volume increase of that bubble into the infinite void space. And that is equated with what we call absolute energy. This absolute energy is the energy of existence. And like the invisible space bubbles, it is not visible to us. Remember that we can't see our universe expanding into the void. It is this invisible volume expansion that generates the absolute energy. What about the energy we can see? As it turns out, the energy we see in our universe is a result of differential expansion between two volumes of universe space. That is, when a compacted group of bubbles, normally thought of as matter, has an incremental change in its expansion rate relative to the surrounding expansion rate of a reference set of expanding bubbles, then we will see this as an exchange of energy. It just so happens that the amount of energy we see per incremental change in volume is constant, so that it appears that energy is always conserved. But in fact, energy is just a product of independent volume expansion and will therefore always be sufficient and in the equilibrium with universe expansion. Remember that absolute volume of the universe in the abyss and absolute energy, the energy of existence, is invisible to us. What I have in this illustration is a representation of space, both vacuum space and space with matter in it. Now, normally these two volumes would be, as we measure them, the same size, but the one with matter in it has more bubbles in it because they are compacted and form the mass that we see as matter. So after time passes, the volume of vacuum space expands when that represents the amount of absolute energy that has been added during the time that passed. That's the energy of existence. And over here with the matter in it, we see that the volume is expanded the same as over here, plus there's an additional expansion which came from some of the matter that was in it. Some of those space bubbles that were compacted have grown in size from what they were and didn't expand in the same proportion as the vacuum space. This change in volume here, this little change in volume right here, represents energy that is released, that we can see in our universe. We can't see the absolute energy here, but we can see the change, the delta in the energy, the absolute energy between what it would be and what it is. So that is the energy that we can see. And for illustration purposes, I've duplicated this down here, and we have another example where the expansion didn't quite meet what the expansion would be in the vacuum space, and it's been restricted amount, so that is a change. In both cases we have a change in absolute energy from what it was, but we don't have as much change here as we had over here in vacuum space. And so what that represents is a negative energy, or a stored energy in this volume. That's energy that can be released later. Now what about time, and when did the universe begin? This again might give you a touch of heartburn. Time is dependent on the linear expansion of space bubbles and is relative to its surroundings. In other words, it has first-order units of length as viewed from the abyss. As the universe invisibly expands into the abyss, time passes. And now we are going to talk about time and how that relates to space expansion. This represents a volume of space. It can be a sphere, and again I've shown this as a two-dimensional representation, which is a cross-section of the section of space that we're looking at. The radius, time is a linear function that's equal to the expansion of universe space into the void. And so this, whatever diameter or radius it is now, represents the total time that the universe has been in existence. And so then we look at it a little later, and we see that the universe, in this sphere that we've gotten here, has expanded a little bit. Okay? And so the change in the radius is equal to the time in seconds passed with expansion. In other words, if we let this be time equal to 0, and this moves out to here, that linear expansion is the amount of time that's passed in seconds. Of course, you'd have to use some sort of a conversion factors to get it in the units that we could see in terms of absolute length. But that essentially is what is talked about when you're talking about time being a linear function of expansion. The energy is a volume expansion. Time is a linear function of expansion in one direction. Since expansion of bubbles may not be uniform throughout the universe, time is not uniform throughout the universe. In regions of slower expansion, time passes slower than in other regions. It is more or less a local observance and depends upon its surroundings. Time is just a record of the invisible sequential linear expansion of space bubbles into the abyss, moving always forward and never backward. Existence is always in the present and comes from the invisible absolute energy that is the invisible volume expansion of space bubbles into the void. We cannot presently exist in the past or in the future. Time traveling and visiting the past or future is not possible. And so with these introductions to time and energy, I'm going to conclude this section lecture. Here are the main things we've discovered. 1. The entire universe consists of expanding space bubbles forced together by each other's expansion and held into configuration by the boundary conditions based on the sharing of sides, non-sharing of space, and geometric configuration of the bubbles. Secondly, the universe had a beginning and an initial size when it first came into being. Third, energy is a function of independent volume expansion of space. There's the absolute energy of existence, which is invisible to us. And there is the visible energy, which is the result of an incremental change in the rate of expansion between two portions of space. Neither type of energy is conserved in the traditional sense. All energy is dependent upon the expansion of space from within each of the space bubbles, and is ongoing as long as the universe is in existence. Fourth, time is a function of the linear expansion of universe space into the infinite void. Time is a local observance, and if expansion slows in a region of space, then time also slows in that space. This concludes this lecture. We will explore gravity and inertia in the next lecture. Thank you for watching and listening.